Hey guys, welcome back to the laboratory. In this video, we are looking at ionic formulae. By the end of this video, you should be able to read and write chemical formulae, identify the relationship between the ion formed by an element and its position in the periodic table, and write the ionic formula for an ionic compound. So, let's go. A chemical formula tells you the number and types of atom that are present in a substance. Here we have the chemical formula for iron 3 sulfate. The element symbols in the formula tell us what elements are present in the substance. Element symbols will contain one or two letters, where the first is always capitalized. These smaller numbers are known as the subscript numbers. The subscript number tells us how many atoms of the element before the number are present in the substance. If an element symbol is not followed by a subscript number, there is only one atom of that element present. And finally, when there are brackets in a chemical formula, the subscript numbers inside the bracket must be multiplied by the number directly outside of the bracket. Now we can use this information to decipher this formula. Iron 3 sulfate contains the elements iron, sulfur, and oxygen. The element symbol for iron is followed by a subscript 2, which means there are two atoms of iron in this substance. Sulfur is not followed by a subscript number, meaning there is only one atom here. However, as sulfur is within the bracket, we must multiply it by this 3 directly outside. 1 times 3 is equal to 3. There are 3 sulfur atoms in this substance. And finally, oxygen is followed by a subscript 4, meaning there are 4 atoms here. However, as oxygen is also within the bracket, we must multiply it by 3. 3 times 4 is equal to 12. There are 12 oxygen atoms in this substance. Here's a quick task for you to attempt to test your understanding of this concept. Pause the video and take your time to work through each question. Press play once you're ready to check your answers. Let's talk through the answers to question 4. This substance contains the elements nitrogen, hydrogen, sulfur, and oxygen. Nitrogen and hydrogen are within the bracket in this formula, meaning their values within the bracket must be multiplied by this subscript 2. There are 2 atoms of nitrogen and 8 atoms of hydrogen. Sulfur is not followed by a number, meaning there is only one atom of sulfur in this formula. And oxygen is followed by a subscript 4, meaning there are 4 atoms of oxygen in this formula. Here are the answers for the other questions. How did you do? Let me know in the comment section below. Now that we are confident with reading chemical formulas, we can delve into the juicier concepts. Let's talk firstly about the ions formed by different elements in the periodic table. There is a direct link between the ion formed by an element and its position in the periodic table. Before we look at this table, let's readdress a few key points covered in previous videos. The group number an element is found in is equal to the number of electrons on its outer shell. When elements react, they are trying to achieve a full outer shell. Metals will always lose their electrons when they react, and non-metals will always gain electrons when they react. Now that we have refreshed our knowledge, this table should be easy to decipher. For example, elements in group 1 of the periodic table will have 1 electron on the outer shell. As they are metals, they will lose this outer shell electron when they react, forming a cation with a +1 charge. In contrast, elements in group 7 of the periodic table will have 7 electrons on the outer shell. As they are non-metals, they will gain 1 electron when they react, forming an anion with a -1 charge. Knowing how to identify the ion formed by an element is important when writing the formulae for ionic compounds. The ionic formula of a compound, much like a chemical formula, tells you the simplest ratio of cations to anions in an ionic compound. The ionic formula of a compound must always be electrically neutral, meaning the charges on the cations must be cancelled by the charges on the anions. For example, magnesium chloride is made up of the ions Mg2+ and Cl-. If these two ions were in a 1-to-1 ratio, the charges would not balance, as there is still an extra +1 charge from the magnesium ion. To balance these charges, you would need 1 magnesium ion for every 2 chloride ions. This ratio is then used to write the ionic formula for magnesium chloride, which is MgCl2. Ionic compounds may also consist of polyatomic ions, which are, as the name suggests, ions containing more than one atom. Here are a list of the most common polyatomic ions found in ionic compounds. Writing the ionic formula for a compound containing a polyatomic ion follows the same rules as seen in the previous example. The only key thing to note here is that you cannot change any charges or subscript numbers on the polyatomic ion to balance the charges. The entire ion as it is comes as one entity. If you change the charge or subscript numbers, you change the ion altogether. For example, magnesium hydroxide is made up of the ions Mg2+ and OH-. Once again, the 2+ charge on the magnesium ion is not cancelled by the hydroxide ion when they are at a 1:1 ratio. You'll need 1 magnesium ion for every 2 hydroxide ions. Remember, you cannot change any of the subscript numbers in the hydroxide ion, so we must use brackets to write the formula for this compound. The ionic formula for magnesium hydroxide is Mg open bracket OH close bracket 2. Now it's your turn to put your understanding of this concept to the test. Pause the video and take your time to work through each question. Press play once you're ready to check your answers. Let's talk through the answers for question 4. Calcium carbonate consists of a calcium ion and a carbonate ion. At a 1:1 ratio, the charges cancel one another out, and so the formula will consist of these ions in a 1:1 ratio. We do not need to use brackets when there is only one polyatomic ion present in an ionic formula. Therefore, the answer to question 4 is CaCO3. Here are the answers for the other questions. How did you do? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!